Mars should have gone quiet by now. Its biggest return mission lost its funding. The rocket meant to launch rocks off the surface was canceled before it ever flew. But a robot with no way home kept drilling anyway, sealing samples that had nowhere left to go. It found something. Nobody in Washington knows what to do about it. The mission that never fully launched. For years, NASA and the European Space Agency worked on a plan called Mars Sample Return, a mission built to do something no country has ever done. Grab rock samples off another planet and physically carry them back to Earth. A rover collects rocks, a rocket launches off the Martian surface for the first time in history, and a spacecraft catches those samples in orbit before flying them home. The price tag told a different story. Early estimates put the mission around $2 to $3 billion. By 2024, an independent review board found the real cost had ballooned toward $11 billion, with the samples not expected to land on Earth until around 2040. Congress balked. NASA reworked the plan twice, trying to bring the number back down closer to $7 billion. It still was not enough. NASA even split the problem into two competing designs. One used a rocket-powered landing system similar to the Sky Crane that lowered Curiosity and Perseverance onto Mars, estimated at $6.6 to $7.7 billion. The other leaned on a commercial company to handle part of the landing and launch, estimated at $5.8 to $7.1 billion. NASA planned to pick one of those two paths sometime in 2026. That decision never really got the chance to happen the way anyone expected. That price spiral is where this story really begins, because it set off a chain reaction that touched nearly every part of America's Mars program. The budget that kept shrinking. In 2025, the White House proposed cutting NASA's overall budget by roughly 24%, which would have been the single biggest one-year cut in the agency's history. Science funding alone was slated to drop by nearly half. Mars Sample Return was named directly as a program to be ended, described by the administration as financially unstable, with the money instead pointed toward eventually sending astronauts to Mars. Congress pushed back hard. Scientists, engineers, and members of Congress from both parties argued that killing the mission would waste more than a decade of work and hand a major scientific first to another country. In the end, lawmakers kept NASA's overall budget close to its previous level, around $24.4 billion for 2026. But Mars Sample Return itself did not survive. A spending bill passed in January 2026 effectively ended the program as it existed, redirecting a much smaller amount toward developing technology for future missions instead. That decision did not shut down Mars exploration. It just meant the rocks already sitting in the Martian dust would have to wait, possibly for a very long time. The rovers that never stopped working. Here is the part that surprises people. While the sample return mission was falling apart in Washington, two robots kept doing their jobs on Mars without pause. Curiosity, which landed in 2012, is still climbing the slopes of Mount Sharp, drilling into layers of rock that record millions of years of Martian history. Perseverance, which landed in February 2021, is still driving across Jezero Crater, an ancient lake bed that once held water for millions of years. Perseverance carries a small drill and dozens of sealed metal tubes. Its entire job for years has been collecting rock samples and sealing them shut, waiting for a ride home that may never come now. By mid-2025, it had already filled 33 of its 38 available tubes, some placed in a depot holding what might be the most important rocks in the solar system. Neither rover can leave the planet. Neither one was ever designed to. They were built to explore, drill, and record, while a separate mission handled getting anything back to Earth. That division of labor is exactly what makes the funding fight so painful, because the collecting half of the plan worked. It is the return trip that fell apart. Before we move on, if you are enjoying this analysis, please consider subscribing. It helps the channel tremendously. One of those tubes holds a rock that changed the entire conversation about life on Mars, and it happened only recently. The rock with leopard spots. In July 2024, Perseverance rolled up to a reddish rock in a dry river channel and gave it the nickname Chayava Falls. The rock had bands of a mineral called hematite running through it, along with strange millimeter-sized light-colored spots ringed by dark material. The science team started calling them leopard spots. On September 10th, 2025, NASA announced what those spots contained. Using onboard instruments, scientists found two minerals, vivianite and greigite, arranged in patterns that on Earth usually form through chemical reactions that microbes use for energy. The rock also held organic carbon, the kind of carbon-based molecules that life depends on, sitting inside what was once a river valley carrying water into the crater. NASA called it a potential biosignature, a specific term meaning a feature that might have a biological origin but has not been proven to. The team published their findings in the journal Nature after specifically searching for a non-living explanation and failing to find one that fit as well as biology did. That does not mean life actually made the spots. It means the pattern matches something biology is known to produce, which is a very different claim from proving biology produced it. NASA's acting administrator at the time, Sean Duffy, called it the closest the agency had ever come to finding ancient life on Mars. That single sentence made headlines everywhere. But a rover, no matter how good its instruments are, still cannot prove life existed the way a lab on Earth can. That gap between a hint of life and proof of life is exactly what the canceled sample return mission was supposed to close. The proof. That's stuck on another planet. Perseverance carries good instruments, but they are built to be small, light, and able to survive a rocket launch and a landing on another planet. They cannot match the sensitivity of a full laboratory on Earth, where scientists can study isotopes, mineral structures, and microscopic textures with machines too large and too delicate to ever fly to Mars. That is the entire reason Mars sample return existed in the first place. The sample drilled from Chayava Falls, named Sapphire Canyon, is sealed in a titanium tube sitting on Mars right now. It may hold the clearest evidence of ancient microbial life in the solar system, or it may not. Nobody can know for certain until someone brings it home and puts it under a real microscope. With the American program canceled, that job may now fall to someone else entirely. And the country stepping up is not the one most people would expect. The country racing to get there first. China has announced plans to launch its own sample return mission called Tianwen-3 around 2028, with rocks expected back on Earth by 2031. It is a simpler mission than what NASA planned, collecting from a single landing site rather than gathering samples across an entire crater, the way Perseverance has been doing for years. But simpler does not mean small. If it works, China could become the first country in history to bring Martian rock back to Earth, potentially including the very kind of biosignature discovery NASA's rover already teed up. Scientists who spent their careers building toward this moment are not happy about the position America now finds itself in. Groups like the Planetary Society have called the cancellation a serious blow to the country's leadership in space science. Committees that advise NASA on planetary science have pointed out that sample return has topped the country's own priority list for planetary science twice in a row, in two separate reports written a decade apart by the National Academies of Sciences. While that race plays out on the surface, an entirely different mission was quietly answering a question about what lies far beneath it. The ocean hiding under the surface. Mars once had rivers, lakes, and possibly an entire ocean, all clearly carved into its surface billions of years ago. When the planet lost its thick atmosphere, most scientists assumed the water either froze solid at the poles or was blasted away into space by the sun. A study published in August 2024 suggested a third option nobody had confirmed before. Researchers went back through years of data from NASA's InSight lander, the same stationary lander that mapped the planet's core using Marsquakes. By studying how seismic waves moved through the middle layer of the Martian crust, a team from the University of California, Berkeley, and Scripps found evidence of a layer of cracked, porous rock soaked in liquid water, sitting between roughly 7 and 12 miles below the surface. Their estimate suggested enough water down there to cover the entire planet more than a mile deep, more than scientists believe filled Mars's ancient oceans in the first place. A separate study published in 2025 pointed to a similar water-soaked layer even closer to the surface, somewhere between about 3 and 5 miles down. Either way, the water is real, it is liquid, and it is completely out of reach for now. Drilling that deep is a serious challenge even on Earth, let alone on a planet 140 million miles away. Scientists reached this conclusion the same way they measured the core, by watching how seismic waves change speed passing through different layers of rock. Waves move slower through rock that is cracked and full of liquid than through rock that is dry and solid. So a layer that consistently slowed waves down became the clue pointing toward water rather than empty space or plain dry stone. The reason scientists care about that water goes far beyond curiosity about where Mars's oceans went. Why wet rock matters for life. Liquid water is one of the basic requirements for life as scientists understand it. On Earth, some of the most extreme environments for living things are not sunny beaches. They are the deep ocean floor and mines miles underground, places with no sunlight, crushing pressure, and almost no oxygen, yet still packed with microbes that get their energy from chemical reactions in rock instead of from the sun. Researchers studying the Martian water reservoir have pointed out exactly that comparison. If liquid water sits in cracked rock deep in the Martian crust, protected from radiation and extreme surface temperatures, there is no obvious reason it could not support the same kind of chemistry that keeps microbes alive in similar rock miles under Earth's oceans. Nobody has found anything living down there. Nobody has any way to check yet. But the ingredients scientists look for, water, warmth, and the right chemistry, appear to line up in a place nobody expected to find them. That same idea of hidden warmth kept surfacing when scientists looked at a completely different feature much closer to the surface. The ground that won't stop shaking. Long before the water discovery, InSight had already found something else strange. Out of more than 1,300 Marsquakes the lander detected during its 4-year mission, over half came from one single region, a network of cracks called Cerberus Fossae, stretching more than 800 miles across a plain not far from where InSight itself was sitting. The quakes coming from that spot had a low-frequency signature scientists associate with warm material shifting somewhere between 30 and 50 kilometers underground. Around the same time, other researchers studying orbital photos found dark, volcanic-looking deposits scattered around the same cracks. Based on how many small craters had accumulated on top of them, those deposits appeared to be only about 50,000 years old, almost brand new by geological standards. Put together, the shaking and the young volcanic rock point to the same conclusion. There is likely still a pocket of warm or even molten material sitting under that region today. A planet scientists once assumed had gone completely cold billions of years ago is apparently still doing something down there. And that reshapes what people should actually mean when they say Mars is dead. So what is actually living there? Here is the honest answer, and it matters to get this exactly right. As of 2026, nobody has found life on Mars. Not a fossil, not a microbe, not a single confirmed biological signal. What scientists have found is a growing pile of conditions that would make life possible. Ancient river valleys and lake beds, organic carbon preserved in rock, chemical patterns that mimic what living things produce on Earth, liquid water locked in the crust, and warmth still moving underground. That is not proof. It is closer to finding all the ingredients for a meal without anyone ever seeing the meal itself. Scientists call this kind of evidence a potential biosignature, specifically because it demands caution. Mars has a long history of exciting findings that later turned out to have a normal, non-living explanation once studied closely enough. The only way to settle it for certain is to get real Martian rock into a real laboratory on Earth, which is exactly the step that just lost its funding. That single fact is what makes the last few years on Mars feel so strange, and it is the note this story has to end on. The verdict: Mars exploration did not stop. 2 rovers are still awake and working on its surface right now, one of them sitting on top of what might be the best evidence of ancient life ever collected from another planet. What stopped, at least for the United States, was the plan to bring that evidence home, cut apart by a budget fight that spanned 2 presidential administrations and ended with a program worth over a decade of work getting shelved. Underneath all of that political back and forth, Mars itself kept doing what it has apparently been doing all along, quietly holding onto water, warmth, and organic chemistry in places nobody expected. Whether anything is actually alive down there remains completely unknown. But for the first time, scientists have a real, specific, physical sample sitting on the Martian surface that could answer the question if only someone finds a way to go get it. Until then, the rocks stay exactly where they are, sealed in titanium tubes, sitting quietly in the dust, waiting for whichever country reaches them first. If you enjoyed this video, make sure to subscribe, and I'll see you in the next one.